This is the supplementary video for lecture 16, where we will solve the problems involving transcendental functions in exercise 12. I will first solve the problems involving logarithmic functions, exponential functions, and leave the problem for trig functions to the last, because the last problem is the trickiest in comparison and is the least likely to appear in the tests. Let's look at number 59. So we want to actually get the absolute maximum and the absolute minimum of this function, f of x equals to x to the minus 2's power times natural log of x. And the range is going to be x between 1/2 and 4. So, well, the drill is the same. You start by dealing with the derivative and using you could use the product rule. This is going to be easier probably using the product rule instead of using the quotient rule. So that will be minus 2 times x to the minus 3 times natural log of x, and then plus x to the minus 2 times the derivative of natural log of x, which is going to be 1 over x. Okay, so what do we have here? So this will be minus 2 to the x to the minus 3 power times natural log of x minus x to the minus 3 power, because 1 over x, this guy is x to the minus 1, and x to the minus 2 times x to the minus 1, that will be x to the minus 3. Okay, so then you can factor out, this should be positive, not negative. And you should factor out x to the minus 3 in the front so as to get minus 2 natural log of x plus 1. Okay, in order to make it easier for us to analyze the derivative, let's write it as a simple fraction. So this will basically be minus 2 natural log of x plus 1 divided by x cubed. All right, so this is the derivative of f of x. Okay, so now let's look at where f prime of x equals to 0. So f prime of x equals to 0, this means minus 2 natural log of x plus 1 equals to 0. So this tells me that natural log of x equals to 1/2. So x equals to e to the positive 1/2 power. So that will be the location where f prime of x equals to 0. Okay, so we should also look into where f of x does f prime of x. Dang. But this is actually out of the domain, so we do not need to worry about this number over here. All right, so that will be the critical number. So we only have one critical number over here. So then at the critical number, the function value is going to be x to the minus 2. That would be e to the 1/2 to the minus 2 power times, well, natural log of e to the 1/2 over here. Okay, so e to the positive 1/2 to the minus 2 power, that will simply be e to the minus 1 power. And natural log of e to the 1/2 power, that will be simply be 1/2. So what we have is 1 over 2e. That will be the function value at the critical number. And at the end points, let's see. So f of 1/2, so this will be 1/2 to the minus 2 power times natural log of 1/2. Okay, 1/2 to the minus 2 power, that will simply be 2 squared. And natural log of 1/2, that will simply be minus natural log of 2. So what I will get is negative 4 natural log of 2. So that will be f of 1/2. Finally, f of 4. So this will be 4 to the minus 2 power times natural log of 4. Okay, so natural log of 4 equals to 2 natural log of 2, and 4 to the minus 2 power, this will go into the denominator. So I should get 4 squared over here. So the answer will simply be natural log of 2 divided by 8, because what I have over here is 16, and 16 canceled out with the 2 over here, that will get 8. All right, so these are the 3 values over here. As you see, well, this is precisely what transcendental functions are difficult, because you need to make the comparison, preferably without a calculator. Okay, so what can we tell from here? So first, it's clear for us to see that this guy is the smallest, because all the other numbers over here are positive. So notice that natural log of 2, so this is going to be greater than natural log of 1, which is strictly, and natural log of 1 is equals to 0. So natural log of 2 is strictly greater than 0. So this guy is positive and this guy is positive. As a result, f of 1/2 will be negative. So that's how we can conclude that absolute minimum is precisely f of 1/2, which is minus 4 natural log of 2. Okay, but how do we figure out the absolute maximum? How do we figure out which one is larger? So this requires a little bit of manipulations over here. So first thing you need to notice is that natural log of 2 is going to be smaller than natural log of e over 8. So that will be smaller. This is going to give us 1 over 8. On the other hand, 1 over 2e, that will roughly be 1 over 2 times 2.718. So this is the rough estimate of e over here. So in particular, it's very clear for us that this guy is going to be greater than 1 over 2 times 3. So if you make the denominator larger, so if the denominator gets larger, so the fraction gets smaller. So that's how you could see that this is going to be larger than 1 over 2 times 3. And 1 over 2 times 3 is 1 over 6. And 1 over 6 is clearly greater than 1 over 8. All right, so what we have is f of e to the 1/2 power is greater than 1 over 8. Meanwhile, 1 over 8 is going to be greater than f of 4. So that way we can tell that absolute maximum of this function is going to be f of e to the 1/2, which is going to be equals to 1 over 2e. All right, so this is how we perform the comparison in problem 59, and this concludes the problem. Okay, now let's look at number 60. So for number 60, so we need to find the absolute maximum and minimum for this function over the interval -3 to 1. So let's just brainlessly start by the derivative. So that will be, well, you need to use the product rule to get 1 times e to the x over 2 plus x times, well, derivative of the exponential function is itself, so that will be e to the x over 2, but then you need to supplement it with the derivative of the inner function, namely 1 over 2. So do not forget this one. So 1 over 2. So this is a common mistake to forget 1/2 over here. All right, so then let's simplify this guy. So what I will get is e to the x over 2. I can factor this guy out. What remains will be 1 plus x over 2. All right, so we see that this guy is defined everywhere. So we do not need to worry about where the derivative does not exist. Now, if we set f prime of x equals to 0, so this means e to the x over 2 times 1 plus x over 2. So this guy equals to 0. But e to the x over 2, this guy is never 0. So you can actually cross it out. So what remains is simply this equation. And then you're solving this equation, 1 plus x over 2 equals to 0. You get x equals to -2. All right, so we already have got one critical number. And let's see its function value. So f of -2 equals to -2e to the -2 divided by 2. That will be -2 times e to the -1 power, or we can actually rewrite it as -2 over e. So this will make it easier for us to perform comparison later. Okay, so now let's look at the endpoint values. F of -3, so this will be -3 times e to the -3 over 2, or we can rewrite it as -3 divided by e to the 3 over 2 power. All right, so this is actually f of -3. And the other endpoint value is f of 1, so which is going to be 1 times e to the 1/2. So this will simply be e to the 1/2 power. All right, so these are the values we obtained, and we need to figure out which one is the largest. And clearly, f of 1 is the largest because all the other guys are negative, so that we could directly conclude that absolute maximum is precisely f of 1, which is going to be e to the 1/2 power. Okay, so what remains is to determine which one is larger. And in order to perform this comparison, I will just handle the second guy, f of -3. I will need to rewrite the second fraction as, first, I will just rewrite 3 as 2 times 3 over 2. So, and then I will rewrite e to the 3 over 2 as e times e to the 1/2. All right, so then what remains is actually to compare if this fraction, 3 over 2 over e to the 1/2, whether or not this guy is greater than 1. But this is actually not very difficult for you to see because 3 over 2, that's roughly 1.5. And 1.5 will be, the square of 1.5 will be 2.25. So that's just actually telling me that the second fraction can actually be written as -2 times the root of 2.25. And at the bottom over here, well, e to the -1/2 is roughly a root of 2.718, roughly speaking. So at the list, I know that this is actually going to be a fraction with the ratio smaller than 1. So I know that this guy, 2.25 divided by 2.718, so this is actually going to be less than 1. Okay, if I multiply both sides by -2 over e, so that I get -2 over e times this radical will be strictly greater than -2 over e times 1. All right, So, but this radical is left-hand side is roughly f of minus 3, but then right-hand side is precisely f of minus 2. So that way you see that f of minus 2 will be strictly less than f of minus 3. So if you're not convinced, that you could also actually change this roughly equals to by a strict inequality. You can actually make it like larger, and all you need to do is to make this number smaller. So for example, I can make it smaller than 2.5. And well, the inequality does not really change over here. All right, so roughly speaking, that's how we do the comparison of f of minus 2 and f minus 3. So our conclusion is, well, the absolute minimum is going to be equals to, is precisely f of minus 2, which is going to be minus 2 over e. All right, so that concludes the problem 16. Okay, let's look at the numbering is a little bit wrong. So this is really problem 66. And the next problem is really problem 67. So I think I get this part wrong in class. But at least on the exercise sheet, everything is clear. So problem 67 will be left for the lecture because this is a very likely problem for test 3. But this one is less likely, so let me just do it in the supplementary video. All right, so we need to find the exact maximum and minimum values. So we will just start by taking the derivative of whatever we have over here. Now, my f of x is actually the summation of these two exponential functions. So the derivative will simply be e to the x times, so this will be the derivative of e to the x. And the derivative of e to the minus x will simply be e to the minus 2x times minus 2 by the chain rule. Okay, in order to simplify this guy, let's just rewrite it as follows. So I will factor out e to the minus 2x. So that way, the first factor guy, e to the x, becomes e to the 3x. And the second guy becomes minus 2. All right, so this is actually the form for f prime of x. And we could also rewrite it as e to the 2x at the bottom, and then e to the 3x minus 2 on top. Okay, so although this is actually a fraction with the denominator, but notice that the denominator is never 0 because it's an exponential function. So as a result, f prime of x is defined everywhere. So we do not need to worry about its where it does not exist. All right, so then now let's simply focus on where f prime of x equals to 0. So this simply means the numerator has to be equals to 0. So that means e to the 3x equals to 2. So e to the anything equals to 2. That means that thing, namely 3x, equals to natural log of 2. So we get x equals to 1/3 natural log of 2. So that will be my critical number. But let's be a little bit careful. So to make sure that this guy is really sitting inside the domain. So we know that natural log of 2. So first, it's going to be greater than natural log of 1, and it will be less than natural log of e. So then natural log of e equals to 1, and natural log of 1 equals to 0. So this is indeed a number sitting between 0 and 1. If you multiply it by 1/3, so then it will still be a number between 0 and 1/3, but such a number is certainly between 0 and 1. So yes, so this guy is inside the domain for sure. So this is actually a critical number, and let's see the function value at this critical number. So f of 1/3 natural log of 2, what is this guy? So this guy will be e to the 1/3 natural log of 2 plus e to the minus 2 times 1/3 natural log of 2. Okay, to compute this guy, the simplest way is to put these front factors into the exponents. So then what we get is going to be e to the natural log to the 2 to the 1/3 power, and then plus e to the natural log of 2 to the minus 2/3 power over here. So then we will just use the inversion rule. So e to the natural log of anything is going to be that thing. So that way we get 2 to the 1/3 power plus 2 to the minus 2/3 power. So you could factor out the 2 to the minus 2/3. So what remains is going to be the first guy becomes 2 to the 1/3 plus 2/3, and the second guy is simply becoming 1. So as you could check, if this guy multiply with the second guy over here, so what you get is going to be 2 to 1/3. And if this guy multiply with 1, what you get is precisely the second guy. All right, so that's the simplification. But then the interior guy, 2 to the 1/3 power plus 2/3 power, this is precisely 2 to the first power. And 2 to the first power plus 1, this will give me 3. So what I will get is 3 times 2 to the minus 2 over 3 power. Now let's keep this number here and let's worry about the simplification of this guy when we do the comparison. So let's look at the endpoint values first. So f of 0, this is going to be e to the 0 plus e to the 0. So this will be 1 plus 1, and the answer will be 2. And f of 1 will simply be e to the 1 plus e to the minus 2. So that will simply be e plus 1 over e squared. So that's f of 1. Okay, so now the problem is actually which one is larger. So clearly 2 is less than e, so that f of 0 will be smaller than f of 1. So that's something obviously seen from this form. Okay, so in order to estimate this guy, and let's actually place everything in the cube root. So first, this guy itself is actually going to be 3 divided by cube root of 4, because that's precisely 2 to the 2 over 3 power. And if you also place 3 inside the cube root, what you will get is going to be 27 divided by 4. So that way, I know that the function value at this number will be cube root of 27 divided by 4. Okay, so I need to compare this guy with, let's say, 2 over here. But if you write 2 over here, so if you write everything in 2 as a cube root of something, that will be cube root of 8. Well, obviously, 27 divided by 4 is much smaller than 8. Yeah, 27 divided by 4 is going to be a little bit larger than 6, but it will be smaller than 7. So that's actually how we can tell that this number is going to be less than 2. All right, so that way we managed to figure out that this is the smallest number, and this will be the second smallest number, and this will be the largest number. All right, so this will conclude the problem. So the absolute maximum is precisely f of 1 equals to e plus 1 over e squared. And the absolute minimum will simply be f of 1 over 3 natural log of 2, and which is going to be equals to cube root of, actually, let me just write it as cube root of 27 or divided by 4, and that should be good enough. Problem 58, so we need to find the absolute maximum and the absolute minimum of the function f of t equals to t plus cosine of cotangent of t over 2. And the region is given from pi over 4 to 7 pi over 4. All right, so the procedure is basically the same. So you start by computing the derivative, and the derivative of this guy, it will be 1 plus, okay, you need to recall a little bit what's the derivative of the cotangent function. The derivative of cotangent will be minus cosecant squared. Okay, so it will be cosecant squared evaluated at the inner function t over 2. Then you need to multiply it with the derivative of t over 2, which is going to be 1/2. All right, so that will be the derivative of cotangent of t over 2. So simplifying this guy, and we write everything in terms of sine and cosine. So what we will get is 1 minus 1 divided by 2 sine square of t over 2. And then let's just write it as a simple fraction. So this way it will be easier for us to find the critical numbers. So writing it as a simple fraction, so the denominator will be 2 sine square t over 2, and the numerator will be 2 sine square t over 2 minus 1. Okay, so this is the form of the derivative, which is easy for us to get the critical numbers. All right, so let's see what happens if f prime of t equals to 0. So this means the numerator equals to 0. So this means 2 sine square t over 2 equals to 1. So that sine square of t over 2 equals to 1 over 2. All right, what do we have? So this way we will get sine of t over 2 is either positive 1 over root 2 or negative 1 over root 2. Now let's see what happens over here. So first, we know that t is ranging in pi over 4 to 7 pi over 4. So this way we will know that t over 2 will range between pi over 8 and then 7 pi over 8. But notice that this is actually going to be contained in 0 to pi. And then within 0 to pi, so sine of x is greater or equals to 0. So this is why we do not need to worry about the situation when sine t over 2 equals to minus 1 over root 2. So then this is not possible in the domain. Okay, now let's investigate what this means for us. So generally speaking, sine of anything equals to 1 over root 2. So this means that thing, in this case, t over 2. So this is going to be equals to 2k pi plus pi over 4, or this guy equals to 2k pi plus 3 pi over 4. So this is the most general solution to this equation. Okay, let me briefly explain why we need the 2k pi over here. So first, if we have cosine function taking 1 over root 2 in one period, so that basically means the function is actually going to be, so this is actually where the sine function takes 1 over root 2, and you'll see that this will be pi over 4 and 3 pi over 4. But notice that sine function does not have only one period. It actually is a periodic function that repeats forever. So this is actually going to give us a bunch of other points where the sine function takes 1 over root 2. So for example, this point is going to be 2 pi plus pi over 4, and then 2 pi plus 3 pi over 4. So those are also 2 points to making the sine value take equals to 1 over root 2. And you could repeat this pattern in general. So over here, so this is actually going to be 4 pi plus pi over 4, and then 4 pi plus 3 pi over 4. And also you could do it to the left-hand side, and then you will see that these 2 points are precisely going to be minus 2 pi plus 3 pi over 4, and then minus 2 pi plus pi over 4. So these are actually all the points that making the sine value to be 1 over root 2. So yeah, this is actually how you will get the general solution. So you need to actually have the solution in the one period, but then you need to supplement it with the multiples of the period over here. So this is why we need to formulate the solution like this. Okay, so this is the most general solution to the equation sine of t over 2 equals to 1 over root 2. But however, for this problem, we have got a domain, and the domain is specified at pi over 4 and 7 pi over 4. So this basically means we need to determine the possible case such that t sits inside this region over here. All right, so let's actually first rewrite it as t equals to 4k pi plus pi over 2, or t equals to 4k pi plus 3 pi over 2. All right, so now you determine what kind of possible case can you take in order to make your t to be sitting between this region over here. So you can see that if k equals to 0, then pi over 2 is sitting between pi over 4 and 7 pi over 4. That's fine. And well, 3 pi over 2, so this is certainly sitting inside here. So these two numbers are fine. But if pi equals to minus 1, or sorry, k equals to minus 1, so then what we get is going to be minus 4 pi plus a number. So this is actually very negative. So this one, we do not need it. Similarly, for the second one, there will be minus 4 pi plus 3 pi over 2. So this is also very negative, so we do not need it. So similarly, for k equals to minus 2, minus 3, and minus 4, so these guys are all very negative, so that the corresponding t values fails to sit in this region. So that's why we do not need to worry about them. Okay, so this basically rules out all the negative possible values for k. Now how about k equals to 1? So if k equals to 1, that will be 4 pi plus pi over 2, and this is obviously too large because, well, what we have over here is something smaller than 2 pi, but so, when k equals to 1, we get something greater than 4 pi, so this is also outside of the domain. And similarly, for when k equals to 1, the other value is going to be 4 pi plus 3 pi over 2, so this is also falling outside. Okay, so this basically means k equals 1 doesn't work, and for even larger case, it won't work as well. So the only possible choices for k such that these two numbers are sitting inside our domain are simply going to be equals to k equals to 0. So okay, so this is basically an analysis, but you do not need to write that much on the test paper. So in the test, all you need to write is since t is inside pi over 4 and 7 pi over 4. So this basically tells us that t equals to pi over 2, or t equals to 3 pi over 2. And writing that much will be perfectly fine because this manipulation is supposed, okay, writing that much will be more than enough because rigorously speaking, under ideal circumstances, well, this implication should have been known in high school. So that's why we do not need you to write it. All right, so this way we obtain our two critical numbers, pi over 2 and 3 pi over 2. Okay, we are not done yet with the critical numbers. We already analyzed where f prime equals to 0. We also need to analyze where f prime does not exist. So this means the denominator 2 sine square of t over 2 equals to 0. Well, this will simply mean that sine of t over 2 equals to 0. So you should learn from the very first few lectures about the trigonometric function that sine of anything equals to 0. That means that thing will be a multiple of pi. So that way we see that t equals to 2k pi. All right. But as you could track very easily, so all these possible choices of k will make the t out of domain. So because if k equals to 0, so t equals to 0, so which is outside of here. And then when k equals to 1, t equals to 2 pi is again out. And when k equals to -1, t equals to -2 pi is obviously out. And for k to be even larger integers or even smaller integers, so they are all out. So that's why we do not need to worry about this these numbers over here. Okay, so what we have seen is, well, t equals to pi over 2 and t equals to 3 pi over 2 are the only critical numbers. Now let's compute the function values. So f of pi over 2, so this will be pi over 2 plus cotangent of, well, pi over 2 divided by 2, what I should get is pi over 4. And you should know that cotangent of pi over 4 should be 1. So yeah, if you're not familiar with this, so just go to the review slides for trigonometric functions. I posted, I think, under lecture 1 or lecture 2. All right, so, and also f of the other critical number, 3 pi over 2, that will be 3 pi over 2 plus cotangent of 3 pi over 2 divided by 2. So I should get 3 pi over 4. And you should know that cotangent of 3 pi over 4, that guy is going to be -1. So this is also the trig values that you should memorize. Okay, so these are the function values at the critical numbers. And now we need to compute the function values at the endpoints. Okay, so but then we see one of the obstructions. So f of pi over 4, that will be pi over 4 plus cotangent of pi over 8. That will be pi over 4 divided by 2. How do we compute cotangent of pi over 8? So this is where we need to use the half angle formula. So the half angle formula basically says sine square of alpha over 2. So this is going to be equals to 1/2 times 1 minus cosine alpha. And cosine square alpha over 2. So this is going to be equals to 1/2 times 1 plus cosine alpha. Okay, so because we are interested in the cotangent, so let's just do the quotient. Let's just divide cosine square by sine square. So that way we get cotangent square of alpha over 2. So this is going to be equals to 1/2 1 plus cosine alpha divided by 1/2 1 minus cosine alpha. So that will give me 1 plus cosine alpha divided by 1 minus cosine alpha. All right, so that will be the formula for cotangent square of alpha over 2. And now let's actually plug in alpha equals to pi over 4. If we plug in alpha equals to pi over 4, then what we get is cotangent square of pi over 8. So this is going to be equals to 1 plus cosine of pi over 4 divided by 1 minus cosine of pi over 4. All right, so cosine of pi over 4, it will be 1 over root 2. So that will be 1 plus 1 over root 2 divided by 1 minus 1 over root 2. So if you multiply everything by root 2, so that way you will get rid of this common denominator over here. So what you will get is root 2 plus 1 divided by root 2 minus 1. Okay, so this is the expression for cotangent square of pi over 8. Okay, so to get cotangent of pi over 8, so we need to take the square root on both sides. And how do we determine whether or not it should be positive square root of negative square root? So the answer is quite simple. So you just need to look at the angle pi over 8. So pi over 8 is actually an angle in the first quadrant. So this means both the sine value and the cosine value, they are positive. So as a result, the cotangent of pi over 8 should be positive as well. So that's why we are actually taking the positive square root instead of negative one. Okay, but then the other problem is actually, so how do we take the square root of this ugly expression? Yeah, in general, certainly such kind of ugly expression cannot be further factorized, further simplified. But for this particular problem, cotangent pi over 8, so this guy can actually be further simplified. And the trick is to rationalize the denominator. So if we rationalize the denominator, so what we have is going to be the following. So that I need to multiply the conjugate of the denominator, which is precisely root 2 plus 1. Okay, let's see what we have. What we have at the bottom is going to be 2 minus 1. What we have on the top is going to be root 2 plus 1 squared. Okay, square root of root 2 plus 1, so that will be absolute value of root 2 plus 1, but root 2 plus 1 is positive. So that means I can simplify my numerator as root 2 plus 1. And my denominator is simply going to be 1. So root of 1 is again 1. So what I'm getting is a simple number, root 2 plus 1. So that will be cotangent of pi over 8. Okay, so this is a tricky computation. So the point is to tell you how to do such kind of computation without a calculator. But don't worry too much. I don't think it will be fair for us to ask such a question in the term test, not even in the final exam, I think. Okay, so this is my cotangent, and as a result, I can compute my f of pi over 4. So this will tell me that my f of pi over 4, so this will be pi over 4 plus my cotangent of pi over 8, that will be root 2 plus 1. So remember, f of pi over 4 comes from here. So I'm just replacing cotangent of pi over 8 by what I computed here. Okay, so we still have another endpoint value, so f of 7 pi over 4. And how do we compute that guy? Well, this will be 7 pi over 4 plus cotangent of 7 pi divided by 8. And because we already know cotangent of pi over 8, so we can use the complementary formula for the cotangent function. So more precisely, cotangent of pi over 7 pi over 8, that will be the same as cotangent of pi minus 1 over 8, pi minus pi over 8. So basically means this guy is the complementary angle of pi over 8. And well, because we know that cosine of pi minus alpha, this is minus cosine alpha. And sine of pi minus alpha, this is sine alpha. So that way you see that cotangent of pi minus alpha being the quotient of these two guys, which will be minus cotangent alpha. So we need the negative sign modification. So as a result, we see that this will be 7 pi over 4 minus cotangent of pi over 8. Now we can plug in cotangent of pi over 8 to see that 7 pi over 4 minus root 2 minus 1. So this will be the function value at the other endpoint. Okay, so now we need to compare these four numbers, and this part is really tricky. It's still possible for us to compare these four numbers without a calculator, as I will show you. But even if you're not following, don't worry too much. It's very unlikely that you will have to perform the same kind of computations in the test. Now, let me organize all the results on the next page, because obviously I'm running out of space. So that's actually what we have. So I have got f of pi over 2, f of 3 pi over 2, f of pi over 4, and f of 7 pi over 4. So now let's actually do some easy comparisons over here. So first, I can compare these two guys. So in order to compare these two guys, I can write the second guy, 3 pi over 2, as pi over 2 plus pi minus 1. All right, so that pi minus 1 is roughly 2.14. because that will be 3.14 minus 1. But then this guy is simply 1. So obviously, you could see that f of 3 pi over 2 is going to be pi over 2 plus a number greater than 1. That will be greater than f of pi over 2. So that way, we could get the same first relation, namely this guy is f of pi over 2 will be smaller than 3 pi over 2. Okay, so let's actually compare these two guys over here. So in order to do this comparison, let me actually rewrite the first pi over 2 plus 1 as pi over 4 plus pi over 4 plus 1. Okay, I want to compare whether or not this guy is larger than this guy. So all I need to do is to compare whether or not root 2 is going to be larger than pi over 4. But root 2 is something greater than 1. and pi over 4 will be smaller than 1. So that way I can see that f of pi over 4 will be the larger one. So that way we see that f of pi over 2 will be smaller than f of pi over 4. Okay, now let's also compare these two guys over here. So we are basically comparing the adjacent guys over here. So f of pi over 3 pi over 2, so this will be 3 pi over 2 minus 1. And in order to compare it with this guy over here, let me just rewrite the second guy as 3 pi over 2 plus pi over 4 minus root 2 minus 1. Okay, so notice that the upper guy over here is precisely these two terms. So in order to determine whether or not f of 7 pi over 4 is larger or not, all we need to determine is whether or not this guy is positive or negative. But we have already seen that pi over 4 is less than 1, which is less than root 2. So this guy is less than 0. So then what does that tell me? That tells me f of 7 pi over 4 being the sum of f of 3 pi over 2 and a negative number. So this will definitely be a smaller number. So that way I can know that this is actually going to be like this. All right, so these are the comparison results we currently have. And now let's see what should we do the next. So we can certainly investigate if these two guys are which one is larger, but that's completely unnecessary because our point is to get the absolute minimum and the absolute maximum. And we know that absolute minimum can only be either this guy or this guy over here. So there's only these two options because all the other guys are actually larger numbers. So let's actually start by comparing this guy over here. Okay, so if this guy turns out to be larger, so that means we need to compare this guy with this guy over here. So that way we will figure out the absolute minimum. But if this guy is already smaller, so it's going to be smaller over here, then this guy itself will be the absolute minimum. So let's actually try that. Okay, so but remember one thing. So this is actually the trick we will use. So a greater than b if and only if a minus b is greater than 0. Okay, so to determine which one is larger, let's look at their differences. So f of pi over 2 minus f of 7 pi over 4. So this will be pi over 2 plus 1 minus 7 pi over 4 minus root 2 minus 1. And be careful, do not forget a parenthesis over here. Okay, so expanding, you get pi over 2 plus 7 pi over 4. And then minus plus 1 plus root 2 plus 1. So I think over here I should have minus over here. Okay, so what I would get is 2 plus root 2 minus, okay, pi over 2 minus 7 pi over 4, that will be minus 5 pi over 4. So I need to determine whether or not 2 plus root 2 is larger or 5 pi over 4 is larger. Okay, so let's get some rough estimates. So first, 2 plus root 2, this is roughly going to be 2 plus 1.414, so that's going to be the rough estimate for root 2. So this is going to give us roughly 3.414. Okay, but on the other hand, 5 pi over 4, so this is going to be equals to pi plus pi over 4. So that will be 3.14 plus 3.14 divided by 4. So this is also the rough estimate. So, but then 3.14 itself is very large, but 3.14 divided by 4, I can actually also do an estimate like 3.14 plus 3 over 4. I don't know how to get the 3.14 divided by 4, but at least 3 over 4, I know that this guy is precisely 0.75. So what I will get is a rough estimate for this guy over here. So that 5 pi over 4 is going to be larger than 3.89. So this is a number that's larger than 3.89, while the first number over here is roughly 3.414. So that tells me that this guy is larger. So as a conclusion, we get f of pi over 2 is going to be less than f of 7 pi over 4. All right, so this means this is smaller than all the other guys, and as a result, we know that this guy is the absolute minimum. Okay, so that's basically finishes the discussion for absolute minimum, but let me actually formulate the solution a little bit later. Let's just finish the absolute maximum as well. So to get absolute maximum, all we need to do is to compare these two numbers. So because all the other numbers are smaller, so if it turns out that this number is is also greater than the other, so that means this number is the largest. So we get the absolute maximum. So if on the other hand, this number is larger, then then we know that this number will be the absolute maximum. So let's just compare it similarly. So in order to compare these two numbers, let's again form the difference. So what we should have is f of pi over 4 minus f of 3 pi over 2. And let's see if this guy is positive negative. So that's going to give me pi over 4 plus root 2 plus 1 minus 3 pi over 2 minus 1. Do not forget the parenthesis. And if you simplify this guy, you will see a very familiar number. So what you will get at the end will be 2 plus root of 2 minus 5 pi over 4. And we have already seen that this guy is less than 0. So this will tell me that f of pi over 4 will be the smaller one. All right, so with this estimate over here, now let's actually formulate our answer. So our absolute maximum will simply be f of 3 pi over 2, so which is going to be 3 pi over 2 minus 1. And on the other hand, my absolute minimum will basically be f of pi over 2, because that's the smallest number, and that's going to be pi over 2 plus 1. Okay, so this concludes problem 58 and also concludes this supplementary video. I'm still feeling necessary to introduce these examples and include them in the course because transcendental functions appears a lot in the real-world engineering and science practices. So it's necessary for me to include this part in the course. But even if you find it difficult to follow, so please do not worry that much. We will not be requiring students to perform the same level of comparisons in the test and in the exams. So the numbers you will have to deal with in the exam will be more or less similar to the numbers you have seen in the lectures. The most important component of the problems in this unit is to perform the closed interval methods correctly. And we will not emphasize such kind of comparison in the tests.